Good afternoon, everyone. On behalf of Neilsoft, I would like to extend a very warm welcome to all of you. Thank you for taking time to join today's webinar on Intelligent Hospital Operations Leveraging Digital Twins for Better Outcomes. My name is Pragya Gupta, and I will be your host for today's session. Healthcare facilities today are expected to balance exceptional patient care with efficient management of infrastructure, critical assets, energy performance, indoor environmental quality, and sustainability goals. As hospitals become increasingly connected and data driven, technologies like digital twins are playing a vital role in transforming how facilities are mentioned, managed, and optimized. Today's session will explore how digital twin enable intelligent operations can help healthcare organizations improve operational visibility, optimize energy performance, enable predictive maintenance, and support smarter decision making. Now, without any further delay, I would like to introduce today's speaker. It is my pleasure to introduce Mr. Dhananjay Dixit, Senior Project Manager, NeilSoft. With over 25 plus years of experience, he has led global programs, managed client engagements, and delivered strong business results. He is skilled at connecting businesses and technology to drive effective solutions and outcomes. Dhananjay brings hands-on experience across the software lifecycle and is known for leading teams with clarity, collaboration, and impact. Today, he will share practical insights into how hospitals can leverage digital twin technology to improve facility operations, optimize energy and environmental performance, and enhance asset reliability. Welcome, Dhananjay Dixit.
Thank
Oh,
you. Thank you,
oh,
Pragya. Sorry.
thank you, Didi. Over to you, Didi.
Thank you, Pragya. And I welcome all the participants in today's webinar. Today, we will be talking about a critical infrastructure, which is hospitals. Hospitals, as we all understand, is a critical facility in terms of making sure that all the patients, all the people who are visiting the facility are essentially served in a best possible way to make sure that they are cured, they get back to their families healthy, and they are worry free. And that is where hospitals, we see that hospitals as a facility, there's a lot of data that hospitals generate. But unfortunately, there is no unique way, there is no unique system by which the hospital data can be visualized, can be analyzed, and the intelligence can be built upon that data, which will help in improving the hospital operations. At the same time, reduce the operating costs, meet the compliances, and also assure the clinical developments that the hospital is promising. So in today's webinar, I would be talking about what are the typical challenges faced by the hospitals and how new technology like digital twins will help in making sure that all of this data is gathered centrally, visualized in a central way, and also analyzed, and insights are provided, which makes the hospital operations smoother. So in my definition, the hospital is actually an industrial plant which operates 24 by 7. Well, if you take a picture of hospital, we have HVAC systems, chillers, compressors, various type of electrical equipments, laboratory equipments, CT, X-ray, radiology department, compressors, chillers, diesel generators, medical gas equipment. Now, these typically we as visitors to hospitals, we don't get to see these equipments, but underlying in the hospital are all of these equipments which are functioning 24 by 7. Only the difference that we see is that the facility, the building which is hospital, it's wearing a low coat of a hospital or clinical coat. Okay. So actually, in my opinion, in my view, the hospital itself is an industrial plant, which is catered for healthcare facilities. And typically, when we talk about hospitals, The the critical infrastructure where there are no off times, there are no holidays. They cannot have any kind of downtime windows. It has to run 24 by 7. It has to cater to patients. It has to provide the assured facilities that are part of the engagement with the patients. Lot of the different elements or the resources that get used in the hospital, like water, air, power, okay, or natural gas. Now, while these get used in other facilities also, these are life-saving critical resources for when we talk about a hospital facility. These are must to have. There is no way those can be replaced. At the same time, it is not just that we can make use of any air or any water. There's a high requirement of the hygiene factor of it, the cleanliness factor of it, and the assurance of it. So that's where these resources are very critical. Also, hospitals being life-saving facilities, these are heavily regulated in terms of what kind of hygiene levels they maintain, how they manage the biomedical waste, how they manage the emissions, effluent, and other energy-related factors within the facility are highly regulated. There are statutory audits that happen. There are internal teams within the hospital who regularly monitor it, but at the same time, there are state level and government level authorities who are essentially making sure that the hospital meets those norms that are defined defined by the government. At the same time, unfortunately, as I said, there are multiple equipments, multiple systems working within the hospital. Unfortunately, these work in silos. These are disconnected systems where there is hardly any mechanism in which these systems can share data with each other, or there can be any correlation that can be formed within this system so as to arrive at better operational techniques or methodologies. And that's where, as I said, hospital, it's an industrial plant with a clinical code. And without any exceptions, they have to operate 24 by 7. They have to make sure all their facilities, equipments run smoothly, no downtime, and so on. So in today's session, we just visited what hospital, how we see the hospital, and talking in context of digital twin, we look at it as an industrial plant, but with having a very different purpose. So in today's session, what I would be covering in about 45 to 50 minutes is that what are the challenges where exactly the hospital operations meeting the compliances are challenging for the hospital as a facility. The hospital staff, including the facility managers, administrators, where exactly they struggle, the challenges that they face. So that is something which I would be covering. Then we will talk about the definition of twin. Where exactly, what is twin? How it helps for hospital or how it applies to hospital as a facility. Then I'll introduce you Enviro Optimus, which is our platform, which is a unified digital twin platform for environment and energy management, and its architecture and what the capabilities that it has, and how it will help hospital facilities to integrate all of these segregated or separated systems come under one platform and provide one meaningful dashboard for hospital operations. And finally, how having this digital twin will gain, what benefits it will give, what are the things that the hospital staff can expect from having a digital twin, and how that will get implemented. So I will start the session today. We discussed what the hospital is, but when we talk about few problems that the hospital facility access have, one I'll talk about first as the energy being the problem, being one problem area. 24 by 7 operations cannot halt. Operations have to work continuously. But at the same time, hospitals' energy bills are one of the biggest factors of the overall operating costs that go into hospitals. So recently we visited one of the hospitals here in Mumbai, and they said that almost 30% of the cost was energy attributed to the energy which is there. And that is where the HVAC systems, the chiller plants, where they have to work continuously. The air circulation hourly air circulation that is mandatory, right? So those things m- make sure that the energy hungry equipments like chillers, HVAC systems, different air conditioning systems, different refrigeration systems have to operate at the optimum capacity, and there cannot be a breakdown into this. At the same time, different medical equipments, you have laboratories, sterilization departments, we have equipments like CT scan equipments, MRI equipments, a lot of equipments are there, which also are energy hungry equipments which are there. And small portion definitely goes into the lighting and the comfort factors that are created based on the hospital surroundings and the hospital total makeover of the hospital. So lighting is also contributes to some of the energy that is getting consumed. And finally, some of the utilities like pumps, medical gas units, compressors, the diesel generator standby, which are there. So those are the things where these are the maximum energy consuming elements within the hospital. But at the same time, when we see the final energy consumption and the bill, the cost associated with it, unfortunately, it's just a one number that we get to see, and there is no way in which we can really attribute where exactly energy is getting consumed, how much it is, why exactly a particular equipment or particular, say, department, let's say oncology department or a radiology department is consuming more. And within that, maybe which equipments are consuming more. Is the chiller actually consuming more than the actual performance parameters and so on? So that is where there is no clear clarity in terms of how the energy spread is happening. We only get to see the energy consumption that is happening in this. The second problem is the environmental factors. And being in hospital, there's a huge pressure, or there are a lot of compliances which need to be regulated, and these are mandated by the government authorities like pollution control boards, then NABH, and so on. So that is where, while HVAC in the simpler terms is simple air conditioning that we think, but when we take that into hospital context, right? It's not just the air conditioning that is going to be sufficient. Air changes per hour, which are mandatory, these need to happen, right? Where various rooms, various regions require different type of pressure uh, numbers, right? So those need to be maintained. But a drift or a change that may happen in these pressurization parameters actually has a huge impact in terms of having these environmental and hygiene and safety related factors which are very important. So those can culminate into some of the incidences which actually require a shutdown, kind of a reinitiating the entire setup, which is a costly affair, and also it's a time consuming affair in hospital scenario. Temperature and humidity. So all of the equipments, of course, they need to be maintained in certain environment, in certain thresholds of the temperature and humidity which are required. And all of these equipments scattered across the facility. There is no connecting thread of these equipments. That is where there's a lot of emphasis goes on having people just visiting those equipments, noting down some of those parameters which are there. And there is no central way in which these parameters come to a dashboard where those can be observed, and any deviations within those can deviations between the thresholds that those have been defined, those can are visible. So that is one factor related to environment, which is finally hospitals. They are one of the biggest consumers of natural resources like water or natural gas. And while they make use of these resources, they are also the generators of this processed water, effluents, and biomedical waste, right? So that is where this ETP performance, which is mandatory for hospitals, that is something which is all of these, whether it is the water consumption or disposal of biomedical waste or your effluent treatment plants, these are all auditable and in the Indian context, these are mandatory requirements for any hospital to have. But unfortunately, while these get audited, these are never instrumented. These are never or instrumented or automated in a way where these data can be visible in real time, can have a proper audit trail for this, all of these plants and all of the material that is being utilized for this. And that is where it only happens where the audit happens, and then the auditors will point out some of their observations. Then only some actions are taken, but there is no way in which these are monitored at a regular basis. So, central board for your biomedical waste, right, or the effluent treatment plant or STP plants. That is where it is important that these are happening. And finally, as I said in the beginning, many equipments. As I said, it's a mini industrial plant. Hospital is a mini industrial plant where there is a building management system. There are different chiller plants, energy meters, flow meters, pressure meters, diesel generators, biomedical waste plants, incinerators, medical gas units, chillers, compressors, many units, many equipments come together to really have this industrial plant running 24 by 7. But unfortunately, there is no integrated way in which these systems can talk to each other, or a correlation between these systems can be defined, which helps in making better decisions. So these systems work in isolated and in silos. There are various people who manage these, mostly manually, or these are governed by BMS system, which are more of a disciplined operations than having intelligence built on for these equipments. So that is where absence of this integration and intelligence layer actually causes a lot of inefficiencies, where some of these equipments will run and consume energy, consume natural resources where the need is less, or there is hardly any need for them, these equipments to run. But this goes this such insights are hidden because there is no integrated way in which this data is seen, right? So disconnected systems and not having a common layer causes a lot of inefficiencies, which which only come across during audit, and there is no single source for the answer for the questions that auditors will raise or the management team will raise. So there is no single way. Everything, although it is related, there is no correlation or linking that is established. There's no cause and effect relationship that can be established because of this uh, isolated equipments. Now, when we talk about the compliance and when we talk about India, I understand we have few participants who have joined from Vietnam, and I'm happy to have audience from Vietnam. This session is specifically for India, but I'm sure in Vietnam, in every country, there are various rules and regulations and standards. I'm sure there are similar standards followed in Vietnam. But when we talk about India as a country and targeting India, there are two norms which are statutory. One is, of course, the Pollution Control Board, which is a central government authority as well as at a state level. So, in like where I am in the state of Maharashtra, there is a Pollution Control Board, and then there is a Central Pollution Control Board. Okay, so treatment of these effluent discharge, okay, or this diesel generator set emissions, right, and the environmental aspects. These are statutory to be followed by every hospital. So without these and during the construction itself, these need to be fulfilled. These have to be shown to the final authority who is going to grant permission to for the hospital to run, and also the biomedical waste, how that biomedical waste is separated, how it is treated, okay, the daily records of it. So these are two statutory requirements when we talk about the India as a country and hospital operations within India. But then there are other aspects also, like NABH or Bureau of Energy Efficiency, or ASHRAE, which talks more on the design standards, like how the HVAC systems should be designed for hospitals, or the NABH accreditation, which is, while it is not statutory, but most of the hospitals require it because of the insurance requirements, right? Because when they want to have hospital insured, also for the insurance companies to recognize that hospital as a, 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 a hospital for which they can grant insurance claims. These are some of those things which are necessary, and most of the hospitals now that are getting constructed within India follow almost all of these rules, and especially the ASHRAE rule, which where the BIM is becoming standard, and they follow this ASHRAE rules, right? So when we talk about hospital as a facility, all of these rules, regulations are important, and these are not one-time activity. These have to be followed regularly, periodically, cumulatively, at set intervals. There are internal teams who are monitoring it. Unfortunately, manually and separately. There is no single window where these things happen. And of course, then there are government regulated audits, which actually happen at periodic intervals. And there, this data needs to be accumulated, shown, say, to continue the certifications and compliances that are required. So this is the scenario when we talk about India. But when we summarize the last three, four slides, we started with defining how we see hospital as an industrial plant with clinical code. Then we saw that, okay, there are many different systems, equipments which work in tandem, but unfortunately, they are isolated. They don't work together. There is no central way in which the data is seen or communicated in that. There are challenges when we talk about energy. There are challenges when we talk about the environmental factors. There are challenges when we talk about the different equipments and working with these equipments. And then there are challenges when we talk about meeting the compliances and ensuring those compliances are met in future as well, right? So, but to do this, all this, data is the key. Data related to your environmental factors, data related to energy consumption, data related to your ETB plants, data related to your care, your chillers and HVAC systems and different things. Now this data definitely is there, but there is no way in which this data can be seen. So the problems that we saw: air safety, effluent quality, waste compliance, management of natural resources. The only gap is that there is no continuous and validated single source of operational truth for the building or the hospital. Now that's the root cause, and that is where almost all of the hospitals that we have interacted with, they have these systems, they have the isolated systems, but there is no central way. And that is where, while they see that, okay, my energy bills seem to be high, but there is no answer as to why these are high or where exactly the issue is. So those are the root causes that we have. Now, we talked about hospital, we talked about the challenges. Now we'll talk about, when we talk about a digital twin for hospital, what it is provided, what it is supposed to give, and what it is not. Because there is a lot of debate, confusion between digital twin as a concept or as a terminology, what exactly it means. But when we really talk about implementing a digital twin for a specific facility or facility where it is built for a purpose, like a hospital or like a data center or like a airport, right? So every facility will have its purpose, and we have to build digital twin around that purpose. So what digital twin is not? Some of the when we talk about digital twin, one thing that people always think that it's a 3D model where I can see my facility in 3D, but actually it is not, because just the looking at just the 3D model, which is a static model, is actually helping us to give see the envelope of the building, maybe see some internal regions of the building by doing some walkthroughs. But there is no operational data. So actually, that digital twin is more like a shadow of your facility. So what we call it as a shadow digital twin, because without having the live data within the 3D model, it's not a digital twin. Because when we talk about digital twin as a concept, digital twin is a mechanism in which we can see the live data. Now that can be overlapped on a 3D model, or that can be with a set of dashboards which are customizable, which generate reports and so on. Okay. Also, people think that digital twin will help in replacing the BMS, or it is more than BMS. Actually, BMS is more of your operations within the facility and which help in giving you the disciplined operations. And digital twin actually sits on top of BMS, where it will help in collecting that data and do analysis of the data. Because typically BMS will help in doing disciplined operations, but when we talk about the analysis part of it, that's where the digital twin plays crucial role. Okay. Second is, it will not guarantee the compliances. So having digital twin, okay, it will help me in compliances unless the digital twin has been implemented in a certain way where it helps in monitoring those compliance related factors and generating reports or automating your compliance certification related activities, right? So it's not a compliance guarantee. And also digital twin as a concept, it's not going to help in giving out the return on investments in with immediate effect. It The gains are absolutely real. It is definitely going to help in minimizing the operating cost, minimizing the energy consumption, minimizing on the natural resources, or meet the sustainable development goals. But it's not. It's a periodic and incremental activity where we start seeing the gains. But what is digital twin in reality for hospitals? It's a live data foundation from the physical model or the physical facility that is there. So all the equipment data, all your operations data is seen live as a central dashboard. That's where the digital twin plays a vital role. At the same time, continuous monitoring of the critical factors within the facility, like energy, water, air quality, state of the various equipments, pumps, the maintenance records, okay, or predictive maintenance. Those are the things which digital twin means, and that is the digital twin that we want to have when we talk about hospital access. And optimization engine which will help in identifying different patterns, different ways in which the energy consumption is happening, ways in which understanding the energy consumption at a granular level, not at a building level, but I should be able to see the energy consumption happening at every floor level, or within the department level, or at the bottommost equipment, which is part of that building. One should be able to see the energy consumption. One should see the operational parameters of it. That is what the digital twin is. And the 3D spatial context is one optional layer to it, where it will help in doing simulation of your operations. It will also help in doing what if analysis. So typically in design phase for hospitals, using discrete event simulation, a lot of the hospital operations can be simulated, and various scenarios within the hospitals can be simulated to understand, okay, what is the planned capacity of the hospital, and with these scenarios, whether that planned capacity can actually meet what has been agreed upon. So those are the things which actually help when we talk about the digital twin. But just having a 3D model of the facility is not a digital twin unless we give life to the digital model. And when I say we give life to it, it is ability to see the data in real time, ability to analyze the data in real time, and ability to get insights from that data so that actions can be taken which will help in minimizing the cost, improving the operations, and improving the reliability of the equipment. That is what the digital twin is. And that is how it should work when we talk about the hospitals. Okay. Now, some of the real situations within the hospital, which actually happen regularly, or these are the potential issues that happen, and that is where having a digital twin will help, because digital twin will help in catching or predicting some of these scenarios ahead of those happening, and that is a game changer, because those things, if such incidents happen, they have a huge impact on the cost and the operation and the working of the hospital, right? So the like operation theater losing the pressure. Okay, so those are the things. If these things don't get monitored on a continuous basis, right? So that can result in infection control breach, right? So those things. So if we are able to monitor these things in real time, then that can be avoided. Or the your effluent treatment plant, okay, monitoring the pH, okay, then various parameters which are there, how the ETP is operating, how ETP is getting processed, right? Now this data, if for certain reason, if this data is not tracked and the operations are not carried away properly, then it can result in the non-compliant discharge, which has a environmental impact and it's a breach. And it being a statutory and mandatory requirement, those needs those things need to be managed well in advance. Then cold chain, a lot of these hospitals will have specific rooms, okay, where certain temperature is maintained because of the infection control, or even some of the medicines, some of the equipments need to be kept at a specific temperature, specific humidity, right? So because otherwise those medicines can become cannot be used, right? So those were like, if it's not planned properly, then it can result in uh, uh, stock being unusable, okay, and wasting on the stock, the material, and of course the material cost associated with it. Then water is typically seen at the just the inlet part of it. Like we just know, okay, this much of water has been drawn by the facility, but there is no way in which we can track where exactly the water is being used. And water has been drawn, same has been used, or if there is a wastage, right? There could be a leakage, there could be some water which is just being used for no reason, right? So that's where those are the things which are important for hospitals to monitor, right? And these are some of the potential failures. Uh, there are many which hospital management and the operations and the facility administrator monitor for it. But unfortunately, it is human centric. People monitor it, but there is no correlation between it, and that has a cascading impact on overall cost management. Okay, then your diesel generators running longer than anyone thinks, right? So how much fuel is getting consumed, at what time the diesel generator started, when it stopped. Okay, there could be some diesel generators which work in this on which on standby mode. How they are performing, how much diesel consumption they are doing, right? So and of course associated emissions which are there, right? So these are the thing. If we are able to catch them in time using a digital twin, using the real-time monitoring, this has a huge impact on making sure that the cost, patient safety, statutory and compliance related aspects and penalties can be avoided or can be controlled. So that is one when we talk about environmental compliance. Now, talking about energy, when we talk about energy, the of course important the chiller efficiency, right? If that happens, then of course it's going to have huge impact on the energy consumption. But the silent energy bleed and midsummer failures with no cooling in critical areas. Okay, this it will help in preventing some of these issues that typically happen. Right? Then low chill water delta or blockages that never sleep. Okay, or the blocks that never sleep. Right, some of these departments in the hospital need to run continuously. Right, with full air handling unit operations. But at the same time, we need to understand some of these departments may not require the air handling units at the full capacity. Right? So identifying those and making sure that any zero occupancy kind of occupancy scenarios are handled well in advance, or simultaneous heating and cooling. Okay, so that is where it is a double waste which can run continuously. Okay, and it's a waste that is happening, and if it goes undetected, then of course it has cost energy consumption, higher energy consumption, and so on. So these are some of the real situations which can be monitored by using a digital twin instead of having them seen in isolated manner. Also, when seen in isolated manner, we don't get to see its impact, overall impact on the entire facility. We only see it in a very isolated manner. But when we see it in overall impact, when we start correlating that with your environment, and when we start correlating that with energy, that is where the insights will come from the digital by having a digital twin. Now we talked about hospital, we talked the challenges the hospitals are facing. We saw some real life scenarios of hospitals where we see there's a waste of energy or there's an impact on environmental parameters. Now I will introduce Enviro Optimus, which is a unified digital twin enabler for hospitals. In the meantime, just one request for audience. If you have any questions, please drop them in the question box so that we can take those towards end of the session. But coming back to our platform, which is Enviro Optimus, it's a digital twin platform built specifically to make sure that for critical infrastructure facilities like hospitals, data centers, airports, and different industrial plants and factories, they can integrate that to have a unified digital twin for monitoring environmental and energy related factors and the operational factors for the facility. And this platform acts as a connective tissue between your physical facility and the various equipments and the systems which are running within the facility so that they can be integrated to have one common dashboard, or what we call it as one common cockpit, where everything is visible and correlation of that data can be established. The data can be analyzed using our platform. So that's the connective tissue that our platform is. This platform actually starts by connecting various equipments, machines, systems like building management system to start ingesting the data that is getting generated in real time. Your machine performances, your energy consumption, water consumption, pressure, flow, and all of this data. And this data becomes basis for your ESG goals or your energy optimization or your environmental and compliance related report generation or automating of some of those reports and the activities related to that. But at the same time, most important thing is this data becomes a, a baseline, or this data becomes input to the intelligence that gets built using our platform. So this data, EnviroOptimus has its own AI ML based framework which can take this data and provide actionable insights based on the patterns and the live data that it is getting, so that those insights can help in optimizing the hospital operations. But when we talk about the architecture of EnviroOptimus, it is built on this, what we call it as a Jenga framework, where it's at the bottom layer, at the bottommost layer, we have the physical facilities like the hospital we have, and it will have your existing systems like building management system, MES or SCADA systems. And also it may have the design data, which is your building information modeling data, where it is asset-rich data. We have the specifications, we have the maintenance cycle that needs to be followed. And now this data is connected using our platform, which is the second from the bottom, the second layer, which is the environment and energy monitoring platform. And this is essentially the platform which bridges your existing facilities. Additional sensors can be added, which are not there. Which this could be environmental sensors, this could be additional energy meters, flow meters, which can be added. And this connective tissue will help in doing three main aspects. One is the environment and energy management, where it will help in giving out insights in terms of understanding various patterns in which the environmental factors are working, how the energy consumption is happening at the granular level. It will also help use that data to do predictive analytics in terms of possible failure events or possible scenarios where the optimization would be helpful, and the asset maintenance, because as it is observing, if it sees any unusual behavior for the equipments like the vibrations or the pressure or unusual change in the temperature, right? So those help in making sure that there is a timely asset maintenance is done before any downtime happens. So that's the platform that which we call it as an entire digital twin. And optionally, it can have a 3D part of it where we can visualize it in 3D. And this can then be customized for specific use cases. So for buildings or for hospitals or for your industrial plants and factories. But when we talk specifically for hospitals, it has very simple four steps operations that is helpful. One is sense the data. So connect with your equipments, connect, start collecting the data, then integrate the data with using your standard BMS systems or different protocols that it has. Then optimize it, define the baselines, define the expected parameters, define how much energy saving we are targeting, use, set the regulated thresholds which are there, and perform the analytics and visualize the data. Start visualizing data, start getting the insights for the facility. Now, when we talk about what exactly a EnviroOptimus as a platform, as a digital twin platform, is able to monitor and show it in a central dashboard, right? So starting with energy, it, as I said, it can go till the last possible equipments to see the data in a very granular way. Then when we talk specifically about the hospitals, then of course your STP, ETP units, monitoring of those units, understanding how those units are working, where are the bottlenecks, which which areas need improvement. Then waste recycling of waste, monitoring that process. Then water, air, and air quality are different are additional aspects which EnviroOptimus helps in monitoring as part of the digital twin framework. And this, for final report, this enables doing reporting for your various ESG as well as various compliance like NABH or pollution control board and so on. So that's where the EnviroOptimus as a platform comes in. Now, these are some screens from the application itself. So on the left hand side, what you see is the end-to-end energy flow visibility. So as the hospital as a facility will have multiple energy sources, right? It will have power coming from the grid. They may have diesel generators. They may rely on some solar power. They may have standby UPS and everything. Now, these are the energy sources, and energy is being drawn from this. But where exactly it is being utilized? Which equipment is using most, and why? Which shift? In what the time frame? What is the pattern? Are there any anomalies in that? Is there any issue with that equipment? Now, this such graphs, or what I call as energy flags, actually help in making right decisions to optimize the energy consumption. And this is backed up by your entire real-time visualization. So all the data that is collected from existing systems or by adding extra meters and measuring devices, this is entirely visible in real-time data. Also, the analytics engine that we have, as I said, we have EnviroOptimus has its AI ML based generic framework, which can connect to any equipment, just define the parameters that we want to watch or we want to monitor, and it will automatically start getting the data, learning from the data, understanding various incidences in the past that have happened, and then start correlating those incidences in the live data that is coming up. So it's it's a 24 by 7 running system where it learns from the past data. It it keeps on getting the live data 24 by 7. It helps in finding patterns. It helps in finding some of the incidences and similarity, and it will help in doing predictive maintenance and giving out alerts which require to make sure that the smooth operations are continued, right? So this is the engine that we have. And that's part of the digital twin implement. This can be implemented. Right? As part of live dashboarding, you can see the data, complete data, whether it's AHU data, whether it is data related to compressors, chillers, where air conditioning units, or other medical equipments. The live data can be seen as a platform, and this can be integrated to with a 3D environment where we can see various type of heat maps, and these heat maps could be for related to your air quality or the temperature and humidity or related to any kind of gas leaks or hazardous gas leaks. Recently, there is a new standard that has come in, which is called as wellness factor. Okay, so it's not just about the operation, building operations, but it is making sure that okay, the environment is more comfortable for whether it is for students or for the employees working in the facility, right? So those kind of calculations can also be automated using our facility, right? But towards end, what I want to emphasize upon is like some of these things which help in like having just a single meter when we talk about operations part of it. First of all, it will help in making sure that all the factors which are there are are maintained in real time, are watched in real time, and actions are taken in real time. It will help in proving the savings. Okay, so it's not just the measuring it, but it helps in taking actions which will save the cost, which will improve the energy consumption, it will improve the environmental aspects of it, and find the possible incidents or probability of having a failure early. Okay, so that right actions can be taken to minimize some of these aspects. When we talk about compliances, okay, all of those, whether it's a CFO who is looking at saving the energy, saving the cost, whether it is the pollution control board who who wants to see the data and historical data, they want to see those registers can be automated, and whether it is the NABH, which is the governing authority in India, they want to see how the waste is handled, the records around it. All of these can be managed, can be monitored using a digital twin as a technology. And now, one thing which we want to talk about is like 3D part of it. One is we saw the dashboarding part of it for the digital twin. Then we want to see how the digital 3D digital twin will help. So of course, by having a digital twin, it helps in making sure that we are able to get a spatial context, a 3D context for the facility, see various heat maps, locate the assets in a very effective manner. So instead of finding out or trying to locate an asset and see the or browsing through different files to see the asset specification, when it was purchased, who installed it, what is the maintenance cycle, and so on. The 3D will help in giving all that information right at the click. Also, it helps in remotely training your staff or doing troubleshooting remotely. So let's say having a 3D digital twin, a person sitting in Mumbai can train a person sitting in Delhi for specific equipment related activities or troubleshooting that is happening, because that way it helps in locating the asset and also understanding about asset in a better way, right? So, and a very important thing is 3D will help in doing root cause navigation. So let's say one air conditioning unit is not working. So by 3D, we can trace the route of that air handling, the ducting part of it, and understand from where it is coming, where exactly it is, what could be the possible solution. But it is not, as I said in the beginning, it is not just a shadow of the building where it is just a static model, not giving out any kind of information. And it will not help in reducing, because reduction or optimization must be backed up by actions which are provided by the digital twin or the Enviro Optimus as our platform. Now, these are some of the examples of integrating digital twin into 3D. Okay, this is like there are different platforms available in the market. One of them is Autodesk Tandem. There's another platform called as D-Twin by Nemetschek. Okay, so those are the platforms where a 3D model can be ingested and we can see asset data specification at the same time real-time data. So on the left-hand side, what you see is the heat map for all the floors, right? So we can see for this hospital building, like how the temperature variations are there across the floors, or we can see if there are any carbon dioxide levels within the facility, or we can trace the electrical system. So let's say one panel, there is an issue with one panel because of issue in that panel, which electrical systems will get affected, right? So that kind of what if analysis can be performed. Now, this is the last slide of my presentation. I hope you guys uh, have some question. I look forward to your questions. But the gains, when we talk about final gains, of course, the hospitals will be able to avoid unnecessary consumption by making corrections in time. So that is important. Avoid compliance related penalties, okay, whether it is effluent plan or biomedical waste or environmental or natural resources, avoid any penalties and avoid incidents because as it being a critical facility, it is very important that all equipments, all systems work smoothly. So by having predictive analytics, it can make sure that the right servicing, right maintenance happens in time before even there is a shutdown or unplanned downtime, right? Avoided labor. Okay. Also, typically the process of having people visiting the equipments, noting down the records where it can be manipulated or it can be missed out. Right? Everything we are automating it, so labor can be avoided. And finally, unlock your capex baselines. Okay, so that's those are some of the gains that one the hospitals will get by having the digital twin. And the process is very simple for the existing hospitals, create the baseline, integrate the equipment that we have, make sure that the more continuous monitoring is happening, which will result in giving out the actionable insights. Okay, and those can be visualized in 3D environment or as a dashboards where this historical data is also maintained, and that data can be used for your compliance related activities, reporting, and so on. So that's the last slide of my presentation. So in short, the journey to the digital twin begins when a hospital gains integrated real-time visibility into its energy, air, water, and waste system. So instead of having all these systems working independently in silos, digital twin brings them all together, establishes relationship between them to better analyze the energy consumption and consumption of natural resources like water and the performance of various equipments, maintenance of it, and predictive aspects of it. So that's all about my presentation and the webinar today. And if anybody from the audience is interested to know more about the platform, please let us know. We can have another detailed session about it. And for any hospital people from hospital facility management, administration, and operations. We can also do assessment of your existing hospital facilities, the equipment, the system that may have, and also provide you insights in terms of how EnviroOptimus can help you to better manage the hospital operations and save on costs. So thank you. Back to you, Pragya.
Ready, we will now move into question and answer session. We have few
Sure.
questions.
Okay.
Uh, can a digital twin be implemented in older hospitals without major infrastructure changes?
Yes, yes. I think a digital twin as of technology can be integrated in older hospitals or older facilities because our Enviro Optimus as a platform has a retrofitting capability. So existing equipments or systems can be fixed with uh, IoT devices, which can help in start collecting the data and feed it to a digital twin system. So yes, to answer your question, yes, it is possible for older hospitals or let's say hospitals which have been built maybe 15, 20 years ago. Yes, yes, it is possible to do that.
Moving to our next question. How do
Mhm.
digital twin platforms address data privacy and regulatory compliance?
Right. So, especially digital twin platform will never communicate or never try to make access to the healthcare or health records of the patient. So that is something which is out of scope for any digital twin, and those are very secured confidential records which every hospital makes sure that those are isolated, those are completely different. So first of all, digital twin now will not make use of or will not connect with the hospital and the health records of the patient. So that is one thing. When talk about the operational data, that's where it is completely isolated. So Enviro Optimus as a platform establishes its own separate network, which is independent of the network that facility has. It works in a very in a isolated in a separate isolated mode. So it does not interfere with existing systems. And that is how it makes sure that this operational data remains separate from your hospital systems. And that is how the data is secure and it is not compromised to any other system.
Okay. What if we don't have BIM data? Can we still get to see digital twin?
Absolutely, absolutely. BIM data is like BIM has been in focus for, I would say, last 10 years, where now realizing the benefits of BIM, most of this new design is BIM based. But surely for older buildings, where there is no BIM data, we can still connect with your existing systems. We can still connect with all, we can add more sensors, we can add more energy meters to your existing system, and that will help us in giving out a dashboarding digital thing. If we want to, if you want to see it in 3D, then definitely we can do a scan to model kind of a mechanism where we do the scanning of your facility and which gets the point cloud data. That point cloud data is actually converted into a BIM. So it has a dual benefit. It's not just the digital twin that you get the design data or your as built as a 3D model. So that 3D model can also then be utilized as a uh, as a 3D model for your 3D digital twin. But yes, to answer your question, yes, even if the BIM data is not there, we can still connect with your physical facility and utilize it to create the digital twin.
Moving to our last question. If a hospital
Mhm,
already has a building management system and IoT
mhm.
infrastructure, what additional value does a digital twin provide beyond visualization and monitoring?
I think the most important thing is moving away from disciplined operation, because when we talk about BMS is going to help the facilities to have disciplined operations. But when we talk about optimizing operations and bringing intelligence in the operations, that's where the BMS is not going to be helpful, because BMS will only help in automating your activities, starting off equipments at scheduled time, turning them off at the scheduled time, right? But whether to start it or not, is it really required? If we have to start it at what capacity, right? So that intelligence, if we want to bring in, that is where the digital twin plays a vital role, rather vital role on top of the visualization part of it. Because one is visualization, but bringing in the intelligence, which will streamline the operations, optimize the energy, optimize your environmental goals. That is where it brings a lot of value.
Okay. Thank you, Didi, for the wonderful session. We hope
Mhm.
today's session has provided valuable insights into how digital twin enabled intelligent operations can help hospitals improve operational efficiency, optimize energy,
Mhm.
and environmental performance.
Mhm.
If you would like to learn more about Enviro Optimus or schedule a personalized demonstration, please feel free to reach out to us. Our team will be happy to discuss your organization specific requirements. Once again, thank you everyone for your time and participation.
Thank you to all participants.